Welcome to the second video on straight line theory for higher maths. This video is going to focus on the midpoint and distance formula, and it'll basically an overview of both of those and situations where you can use them. First learning intention is I want you to understand how to calculate the distance between 2 points and be able to do this for various scenarios. Well, let's look at an example. If we were asked to find the distance between the points A, 2, 1 and B, 6, 6, if we plot those points, you'll see the distance is the blue line joining A and B. Now, from National 5 work, you should have done work covering Pythagoras, which looks at finding distances between two coordinates. Well, to do that, we can use Pythagoras. We can create the right-angle triangle by doing the distance along the x, which in our example is 4, and the distance up the y, which in our example is 5. That will always create a right-angle triangle if you look at the x distance and the y distance between the coordinates, which allows us to apply Pythagoras theorem in order to find the longest side, which will always be the distance between the 2 points. So if A to B is our length, is our side C, and 4 and 5 are labelled A and B, we can sub that information into Pythagoras' theorem and rearrange it to work out what C is. So if we add them, we've then got to make it C the subject, not C squared. We would have found that the length, C in this example, is 6.4. So the key element to take away from this is that the distance between any 2 points is always basically just using Pythagoras to find it. From this Pythagoras, it does lead to what is known as the distance formula, which is length AB, or whatever two coordinates are labelled, will always be equal to the square root of the difference between your x coordinates, which is x2 take away x1 squared, plus the difference between your y coordinates, y2 minus y1 squared, added together. This basically comes from Pythagoras. If you take two example coordinates x1, y1 for A and x2, y2 for B, well, the difference for AC in the x coordinates is x2 take away x1, and the difference for length BC is the difference between y2 take away y1. Summing them into the formula for Pythagoras gives us x2 minus x1 squared plus y2 minus y1 squared. But given that we want AB, not AB squared, if you square root it, you will see where the formula for the distance formula comes from. And it's basically just Pythagoras. Key element, remembering the distance formula does actually cause problems. So I would prefer you just to remember that it's using Pythagoras. And from that, you can kind of always work out the distance from first principles instead of having to remember the formula, where some pupils sometimes mistakenly replace the minus with a plus inside both of the squares. Example for you to try. Using the distance formula, if I've been asked to find the distance between these two coordinates, subbing in the coordinate points, be careful. Again, as it always is at higher, some of the biggest problems experienced are where kids forget to double negatives, scenarios like that. And in this scenario, we've got the double negative beside the 6, so that will become a plus. So it ends up being 8 squared plus minus 6 squared. Again, the squaring process removes any negatives, so make sure you do that. And it turns out we're looking for the square root of 100, which gives us a distance of 10. Now, as I said in the previous slide, you don't have to use the distance formula. There will only ever be one mark available for the distance. So the method you get to it is up to you. Personally, I look at the difference between the x and x1 and x2 coordinates, which difference between minus 6 and 2 is 8. I look at the difference in the y, and I find that that's 6. I then just sub that into Pythagoras and work it out from there. And it turns out you don't actually need to show any of that difference process. That can be done in your head, and all you need to show is the Pythagoras part of the formula for calculating the distance. So either way is acceptable. It's just up to you which way you prefer. Now, next learning intention is I want you to be able to calculate the midpoint between two fixed points. So there is a formula for finding the middle point between two sets of coordinates. So if you have A and B here, the midpoint, which as the name suggests, lies in the middle, is given by the following formula, which is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Basically, all that formula does is find the average value. If you add x1 and x2 together and divide that answer by 2, it will give you the average of those two, which will be the midpoint x-coordinate. And doing the same for y will give you that. It's also important to note that this midpoint formula does include finding the midpoint of a straight line which is fixed between 2 points. Obviously, a straight line continues indefinitely, but we can fix the straight line for our context between two set points, and that allows us to use the midpoint to find the middle of that line. And remember, the formula effectively finds the number that lies halfway between the x coordinates, and the same for the y. That's its purpose. So here's an example to try, which also includes a question on the distance formula as well. So for the following two coordinates, we've been asked for A, to find the distance between them, and B, the midpoint of the straight line between them. Well, to find the distance, use the distance formula or the Pythagoras method that I showed you previously. Subbing in the values, again, watch out for any double negatives. It turns out that we're trying to find the square root of 74. Again, it depends on the context in the question. It's not a problem if you leave the answer as a root in its simplest form, which in this case is root 74. Part B wants the midpoint. Again, use the midpoint formula where you add the two coordinates. Watch out for any double negatives or doing a negative take away another negative, all those sort of scenarios, just to make sure you get the right number on the top. And it turns out that the midpoint lies at a fraction, which is minus a half. Now, you can't do the midpoint without the formula. Again, recalling the midpoint formula can cause problems because what you find that happens, certainly from prelim marking and class marking, that I find is that they mix the two formulas up and you get a kind of hybrid, which obviously isn't going to get you the distance, or a hybrid midpoint, which isn't going to get you the correct midpoint. I would prefer you to work from first principles, but you don't have to. But if you do work from first principles, you can look at the two x coordinates you're given and just decide what number lies on that number line halfway between. And if you do the same for the y, you'll have found the midpoint formula, midpoint coordinate. Now, the key thing to understand here is, again, you will only get one mark for finding the midpoint. So the method you find it is irrelevant in your higher exam. So it's just more that you get the correct midpoint. So stick to the way that suits you best. If I do it the non-formula way, what I do is I look at what's halfway between minus 5 and 3. Some of you will be able to visualize that number line in their head and straight away work out that it's minus 1. However, another way is to look, what is the difference between minus 5 and 3? Well, that's 8. If you need to move 8, halfway would only be 4 of those. So if you come up 4 from minus 5, you would end up at minus 1. Or you come back 4 from 3, you end up at minus 1. So that's another way of looking at it as well. Doing the same for the y, what number lies halfway between 7 and minus 3? Well, for those find this method quite straightforward, it's 2. But you can also, again, look at the difference. The difference is 10. Well, half that difference is 5. So you either move 5 back from 7 to get to 2, or you move 5 up from minus 3. Again, the method is irrelevant as long as you get the midpoint being minus 1, 2. You don't have to show your method. If you can look at, what was it, two coordinates, work out their midpoint in your head, you can just write it down. Again, do what's best for you and what fits.